We're going to talk about functional programming with the Arrow library in Kotlin. So I'm Rahul Dominic. I go to the University of Waterloo and I'm in the last term of my third year. A little while ago, I did another talk at the meetup, about functional programming in Kotlin, where we went over some of the basics of how to start with functional programming, what are the benefits, and how do you get started with Kotlin. So, how many of you were here for the last talk? Okay. So I thought that I'd sort of start out with like a short recap to refresh everyone's memory about why we should care about functional programming in the first place. So functional programming is essentially programming with pure functions. Pure functions are the basic units of computation in any functional program. And what does this mean? Pure functions essentially have no side effects, which means they don't do anything that is not explicitly mentioned in like their interface, and they're deterministic, which means if I call a pure function with the same inputs a million times, I'm going to get the same answer a million times. This means that it's super predictable. And when you have things that are super predictable and can only do a small number of things, you get code that is easier to reason about, easier to read, and safer and bug-free. One additional benefit of writing code more functionally is that it improves code reuse a lot. And this is sort of the part that we're going to touch upon today. We're going to talk about how functional programming sort of draws out these patterns that can be abstracted away to make it easier for you to write code and for you to focus on what you want to do and leave the behavior aspect of things to data structures. Yeah, and that's where Arrow comes in. So Arrow is a library in Kotlin for typed functional programming. So what that means is that Arrow provides a whole bunch of abstractions for you to use out of the box to basically write more functional code and for you to reduce the amount of boilerplate that you have to write to achieve these things. So let's start off with a small story. One of the hardest challenges for me when I was trying to figure out functional programming was, why does this all matter? How did people come up with these crazy abstractions and weird names and everything like that? What does it all mean, right? So let's start with a single pure function. So we have a simple function, f of x, and all that does is it takes the input, it multiplies it by 2, and then returns it. Great, easy. Now we have a second function, a function that takes an input, it adds 1, and it returns the result. Also simple. But in procedural and imperative programming, we have the ability to order the way that we write code. So what if I wanted to say, okay, I want to take an input, I want to add 1 to it, and then I want to multiply it by 2. How do you model the then? And that we can probably think of as function composition. So if we try to say, okay, first let's apply g of x, and then whatever the result is, we will apply f of x to that result, then we essentially get the value plus 1 and then multiply it by 2. Great. But now what if I change g of x to be something like this, to take in 2 inputs and divide instead? Then the possibility that y is 0 exists. So how do we handle errors in a purely functional world when everything needs to have inputs, outputs, and you can't have like throwing exceptions and catches and stuff like that? Let's zoom in on the function and look at the contract. So we have g taking 2 float values, let's just presume, and it outputs a float because floats is a float. But is that really what we want? Like, what is something divided by 0? It's not a floating point number. It's something else, and we really can't model it that way. Do we really care about it? We know so little about it that we really don't care about it, so it's essentially nothing. So what we really want is something that returns either a floating point number or just nothing at all. But we really can't return two things from a function. A pure function can only return one thing. So what ideas do we have? Maybe we could create a sort of box, and the box could either be full or empty. If it's empty, we don't care about it. We don't do anything about it. But if the box has a value, then that is something we need to care about. Okay, so we have g of x, comma y. We apply it, we get a result, and then we check. Okay, is it full or is it empty? Because if it's full, I care about the value. I want to do some processing. If it's empty, let's just ignore it. So this works. Let's step back into our original problem. Now, if we try to compose f of x and g of x comma y, we get a compiler error because this no longer type checks. We don't know how to apply something multiplied by 2 to some box that we created. But again, let's think of it as, what did we really want to do here? We wanted to get the result, like whatever's in the box, we want to multiply it by 2. So how do we do that? Every function that operates on this box of float, everything that can error out, we don't want to rewrite all of them to use this new data type. So what do? So this is one thing. We want to transform the value inside. So we could just write an extension function in Kotlin to take whatever the value is inside, change it using that function, rebox it, and return it. That's something that might actually work. And what does this remind everyone of? Everyone's probably seen this before. It's just mapping over a list. It's the same idea, except in this case, it's a list of size either 0 or 1. And this is an actual thing in Kotlin, well, in functional programming, and it's called an optional type. And it's the same as like having nullable types in Kotlin. So it either has something or it has nothing. And the operation, just like lists, is called map. Turns out this is such a common pattern to have this abstraction, this box that contains things, and you need to map over it. It's so common that it has a name, and it's something called a functor. A functor is just a weird name for something that represents an abstraction over any transformable data. So if we look at the interface, it's just anything that has a map function. So we will get into what kind f comma a is in like the next slide, but just assume that it's optional for now. So optional, we have a function called map that takes another function from type A to type B, and it returns an optional of type B. So optional of type A, a function from A to B, and then an optional of type B. That's essentially all a functor is. So the kind is something in functional programming called higher kinds. Again, these are all scary names. We will get to exactly what they mean. So a higher kind is just a way to represent a generic container that can contain things. So if you think of a list or an optional or any of those types, it's a container that can contain things. But what if I want to be so general that I am talking about any container that can contain things? And that's what a higher kind is. It's represented by kind f comma a, where a is the type of the objects in the container, and f is the type of container. So if I want to talk about a list of integers, it's kind list comma integer. So it's just a way to generify the containers and the kinds that they hold. And we'll see why this is so important in just a couple of minutes. So this is actually the code that that Arrow uses to write option. So we see that we have a surrogate class called forOption that, for all intents and purposes, like you never usually see. Well, you see it, but it's hidden behind the actual option type. And then we have a sealed class option, which inherits from kind, or rather implements kind, for option comma a. So that option class is what you most generally interact with. It's generic on a type A, and it implements the kind of for option, which is the surrogate class, and the kind A. So all it's saying is that, hey, I want this to be a container of type for option, and it needs to hold things of type A. Now the reason for the for option thing even exists is because it needs you need some place to add these extension functions, and you're going to see the use of this in like the next slide. And because we're using this other kind sort of as like a backing, we need to have a way to safely downcast it to an option of type A, and that's what the fix function is below that. We know that this is safe simply because we only have one thing that implements that, so we can safely downcast. So the last thing for the moment is called type classes. So type class is essentially an interface that contains extension functions that are associated with some type. So in this case, functor is actually a type class. So if we look at how it's actually implemented, we can see option functor, which is how we actually get all the functor. We get the map function on options. We see that implements some class. Well, implements the interface functor specified by for option, the surrogate class we defined up there. So within this class, all we do is we implement map. So we implement how option handles map, and in this case, it's going to be, if there's something, use the function to map over it, otherwise just continue with nothing. So that's essentially what that does, and the extension annotation on this is where all the magic happens. So what it does is, it tells the compiler it tells Arrow that, hey, this is a type class. So what I want to do with this is I want to create some object, some static class somewhere that implements this with all of these default members, and take that that object and add them as extension functions to whatever is the specified type within the generic there. Yes, question.
What are the benefits of type classes compared to regular Kotlin extension functions?
Right. So type classes, one of the benefits is that you can use these with pre-existing types. So for example, lists. Like you can implement type classes for lists, and actually the benefit of it comes from the extension of kind f comma a. So in this case, kind for option comma b. It gives you the ability to be polymorphic on the type of container you have. So a lot of times you can write functions that depend on some kind or some specific behavior of kind. So I can say that I want so some specific behavior of kind without really specifying what exactly we want. You're right in that it is extremely similar to interfaces, and in this case in Kotlin, it's sort of a hack to get type classes to work. However, there is a proposal open with Kotlin to integrate type classes directly with to integrate type classes into the Kotlin compiler, which will make it sort of more useful. There are some things you can do with type classes that you can't do with interfaces, and that's sort of the main differentiator. We can talk more about this. Yeah. So yeah. Are there any other questions? Because it's sort of important to understand it every step. No? Okay. So let's look at another example. Let's say now you're back and you have your optional data type. We know it's an optional. We know the kind of operation it has. We know it implements functor, which means it has a map operation. So now, what can we do with it? We want to, let's say we have two separate optional values, and we want to apply a multiplication function to it. So we want to multiply the values into two. So with the amount of knowledge that you have right now, it's very possible that you would write something like this, which is take the first optional, map over it, take the second optional, map over it, multiply the two, and just return from the numbers. That wouldn't work because you now get like a nested optional of optional of optional of integer, when in reality you want optional of integer. So you need some way to flatten this out. In lists, if we're looking at regular lists, then probably everyone's heard of a function called flatMap. And that's exactly what it does. It takes lists of lists and it flattens out a layer. And that's sort of what we need. We need some sort of flatMap operator to say, okay, I'm going to flatMap on the first one. The second one is going to multiply. The second one I'm going to map over. I'm going to multiply the two values, and this will return an optional type int. So only if both of them actually have a value, and only if neither of them are none, will this continue and return an optional type int. And turns out this is also a super common pattern to have in super powerful abstraction, and it's called monad. And this is probably one of the things that has. There are literally libraries about monads, like libraries written about monads on the internet. If you type monad on Google, you're going to get like a million different articles. So monad, just like a functor, is a type class, but this abstracts over a whole bunch of things. It abstracts over data, it abstracts over control flows, like lists, maybes, and futures. We're going to talk about all of these soon. It's an abstraction over side effects. So all of these, it abstracts over anything that essentially is a context over some data. So if you think about an optional, or if you think about a list, it provides context over some wrapped value. So an optional means it's either going to exist or it's not. That's the context over the integer that you're wrapping. If you're wrapping over a future, it's something that is either complete or not. It's something that failed or succeeded in terms of, in the case of the result. So it wraps some value with some context. And often these are called effects for that reason. So a monad basically contains two methods. It contains one, which just wraps any basic type in a monad, and another that helps compose functions that output monadic values. So I will explain what that means. So in the first case, it's pretty simple. You just need some way of instantiating a monad, of wrapping some type in a monad. In the case of an optional, if you have a value, you wrap it with a sum. If you have no value, you wrap it in a none. In terms of compositions, let's say that some computation occurs and returns an optional value of 3. Now I have another function that takes some input and it returns an optional, and basically it returns an optional which indicates whether the input is even or odd. So we have the function keep even up there. So what it does is if the value is even, then it returns it as sum. Otherwise, it just returns nothing. How do we apply that function to the first monad? In a sense, we want to chain the values. So how do we do that? We use the flatMap operator. So monads are super powerful in that they give you the ability to chain operators and to sequence events within monads. And this is essentially the interface. It's the exact same. Type of interface that we've seen in the software functor. It's an extension on a kind of some random container on a higher kind, and it returns the mapped version of that. So the only difference between the map and the flat map is that the mapping function, instead of returning, instead of going from A to B, it goes from A to some wrapped value B. Are there any questions? Is everyone sort of following where we are? Cool. So now we're going to talk about some common patterns of where we use monads, how monads come to resolve them, and how they really help us in our day-to-day work. And I need to start off with exception handling because this is sort of the most common use case. So let's look at this exceptional code. We have the first function which basically throws an exception if the input value is even. Otherwise, it throws an exception if the input value is odd. Otherwise, it just returns the number. And we have a caller function. So the traditional way of handling this would just be to wrap it with a try catch and handle the exception there. Why is this bad? So in functional programming, one of the properties of pure functions is something called referential transparency. What that means is when a function is deterministic, you know exactly what it's going to return. So at its call side, if you know the input for the function, you know exactly what that function is going to return before the function even executes. So you could change the value, you could change the call side with just a single variable that represents the return value and run your program, and it's going to function exactly the same. So referential transparency is that property, essentially. And when you have exceptions, it's bad for a couple of reasons, and it breaks referential transparency. So this is no longer referentially transparent because I can't really, so if I pass in an odd number, I cannot replace it with some other value and have the code run just the same. The second thing is when you have exceptions. Exceptions are super taxing in terms of efficiency because every time you throw, you need to generate a call stack, stack trace, and it doesn't work on like asynchronous boundaries. So you have a lot of issues with them. But I'd say the biggest and most trivial issue is just that sometimes people forget to catch exceptions. Like you don't look at the implementation, you don't know this is going to throw, or you just ignore the fact that it's going to throw, and it causes a runtime exception. So this is something that we want to fix with functional programming. So let's look at how we handle exceptions and error handling in functional programming. So let's start with a real world example of just having like a simple block. So you have users. You have three functions. You have one to get a user object. You have one to get the post associated with the user, and you have another function that is essentially a composite of the two. It says, give me an ID, and I'm going to get the post for that user. So if we look at this is the super traditional way of doing it with exception handling. So you have the functions, they throw exceptions, and in the get user post function, we have error handling to catch when that throws and does whatever. So let's use the knowledge that we have with optionals and see how we can fix this. So we look at the get user and the get post function. We can move the try and catch up there and say, okay, if something throws, so if there's an error, I'm just going to return a none. There's no value, I don't care about it, an exception is thrown. Otherwise, I'm going to wrap the result in an optional and I'm going to return that. So now our So now that this works pretty fine, except for the fact that we still have that try catch there. It would be nice if we could just get rid of it. So we could do something like this. Luckily, the library itself has a way to return sort of a wrapped exception. So we can just check if the request failed or succeeded, and we can then return an option to wrap that information. Yeah, pretty straightforward. This is what the get user post function looks like. We have now no exceptions being thrown, so we don't need to have the try catch there. So now let's actually fix up this code to do something. So instead of passing like a user secret, let's unwrap the optional, and use the user secret. So we get something like this. Since we want to call get posts since we want to basically chain the first monad and then return a second monad in the transformation function, we want to use a flag map. So we basically call get posts within the flag map, and all that does is it takes the user secret, it goes and gets the post, and then returns another optional. So great, now this returns an optional. This all works fine. But one problem is that we don't know what caused the exception. We don't know if it was a JSON parse exception, if it was anything, a network exception. So how do we solve that? So we have another type of monad that Arrow provides called the either monad. So either is just an OR type that can either have a left-hand value or a right-hand value. So a left-hand value of type A or a right-hand value of type B. And either is right biased. What does that mean? When you call map and flag map on an either, it always operates by default on the right-hand side. You need to explicitly state whether if you want to operate on the left-hand side. And that's essentially all it is. It's another monad that gives that gives you the context of I can either have a value A or a value B. So now we see that we can do something with this. Now we can see that we can either have a throwable to mark that, oh, we have an exception, or we can say that we have the actual value. So the first function can return a throwable or a user, and the second one can either return a throwable or a list of posts. So it's essentially the same thing. We have extension functions that are provided by Arrow called left and right, and all they do is if we say right, it generates an either with whatever the value is being the right hand value. With left, it's the opposite. It's the cool. Now that works. So what does our get user data look like? Looks exactly the same. It's a monad. It has a flag map operation. But we do one extra thing. We don't want to return like the throwable back to the user because of a lot of reasons. One, it's abstract. We don't want to have networking. We don't want to have network errors filter back to the view or the presenter or anything like that. And we probably also just want to send the information that's necessary. So we can have like a simple function that just figures out what the exception is and then returns a string to print out to the user or something like that. So here we call map left. We call it explicitly because we want to map the exception on the left and we don't want to touch what's on the right. And yeah, this works. So I just wanted to step back to this for a second. So there is actually another way to handle this that I have not mentioned. So we see the try and catch there. So Arrow actually has something called a try monad, which basically takes a block, and if an exception is thrown within the block, it marks it as a failure. Otherwise, it's a success and it wraps the result that's returned. The reason I did not show this is because in the next version of Arrow, this is deprecated. So it's eventually going to be removed in the future. And the recommended way is to use either now. So either with a throwable and of type A is the same as using a try of type A. So yeah, I just wanted to mention that in case. Yeah. So let's step back to this. Does anyone see an issue with this code? but like something like a lot more like fundamental. Sort of those lines right there. Anyone have an idea? Yeah, so the issue is that this is synchronous. So this is going to block your main thread if you run it. So how do you handle asynchronous code in a functional style, like without calling callbacks and stuff like that? So Arrow provides something else called an IO monad. Actually, before I get to this, does anyone have any questions? Because it's only going to get more complicated. No? Okay. So an IO monad is a data type that literally just wraps side effects. So it wraps side effects in a functional language, and this originated from the godfather of all functional languages, Haskell. And it's just a way to wrap operations that are lazy evaluated and wrap operations that can potentially fail. So all IO does is it creates a thunk with the function that you pass in, so that you don't have to run it right away. And because it's a wrap type, the context for the IO monad is just that you want to run some sort of operation that does side effects. So let's see how you use it when you're making network calls. So all you do is right where your code is, you would just wrap IO and like a big block around it. And what that would do is it would create essentially a recipe. It will return an object that has a recipe of how to do that, of how to make that network call. So unlike like a regular function, when you call this function regularly without the IO wrapped around it, it's going to execute the network request right away. But when you wrap an IO around it, it essentially defers the effect. So you have an object with a way to make a HTTP request, but it doesn't do it yet. In functional programming, you want to defer effects as late as possible, so you retain purity as much as possible. So all this does is it wraps both those calls in an IO, and you can see that the return type now just changes to an IO. So this is what the user posts would look like. Essentially the same thing. You have the first IO, you flat map it to the second value. Still nothing has run yet. And then right at the end, when returning, you run something called unsafe run synchronous. Don't do synchronous, do async. I just did this for demonstration purposes. But yeah, what that does is unsafe, because in a very functional program, if you're writing it like very functional, you only want to have one site where you ever do unsafe run, so where you run your side effects. In this case, this is in the networking layer. Don't dare be in the networking layer. If you're doing Android, it needs to be in your activity, or if you're doing like a CLI, then it should probably be in your main function. But yeah, so when you say unsafe run synchronous, what it does is it executes all of the code that you have. And because IO wraps any throwables, it returns an either of throwable and the result that you want. So at the end of this, what this is going to do is it's going to say, okay, let me run the first thumb, which is let me get the user. Oh, and I see someone flat map. So let me run whatever's in the flat map operation, and then it goes and gets the posts. If any exception has occurred, it will catch them. Otherwise, it just goes ahead and it returns an either of the two values. And then because it's an either, we can use the same function to map on the left. And there we go. We have the exact same things. So you change this to asynchronous. The only thing that you have to do is it will no longer return a value, of course. It's going to take a callback within it. So that is again, something that you probably want to do in your view layer, whatever that is. Cool. And, yeah.
So for I/O asynchronous, do you mean lazy or is it truly asynchronous? Is it like coroutines?
Yeah. So that would run a synchronous call if you say run sync. Run async would do an actual asynchronous call. So this would still block, but yeah, if you just say run async, it'll work the same. I/O in general is like always lazy, unless you really want it to not. So you can do the good thing about Arrow is that it provides integrations with most popular libraries out there. So it has integrations with Kotlin coroutines, it has integrations with RxJava, as well as Flux. So you can do stuff like this. Instead of wrapping with an I/O, you can wrap with an async. And then you get like a deferred of whatever. So in this case, you get a deferred either because we're wrapping stuff this way. We're returning an either from the function. And then you can do the same thing where you await the results, you flat map, and then you map finally to the left. So this essentially remains the same. And this again comes from like the reason you can do stuff like this is because of type classes and the generic and higher kinds. So that sort of ties back to the point that you were making about interfaces. This is like having this level of generality is a little bit more difficult to do with existing classes if you're using interfaces. So yeah, this is just a single level of flat mapping, right? So this looks just fine. What if you had something like this? What if you had get all posts for every user, and you have two users? So then you have user 1, user 2, you await the results from those, and then you await the results from the post. So you have like two more flat maps, and then you finally return like a flat map, a map, and then combine it, and then wrap it to the right, and then all of that. Who thinks this is readable? So you get a lot of benefits from monads, but then you also have to write code like this, right? So there are solutions to that, and it's called monad comprehensions. So people recognize that it's easier for developers to write code sequentially. So monad comprehension is just a way to compose monads in a way that is essentially sequential, and it's the same syntax that you would use for coroutines. So you'd have something that looks like this. You'd have a flat map, and inside flat map you do some stuff. But when you use monad comprehensions, it becomes something like this. So let me step through what this means. So if we look up here, we see that you want to invoke something with an I, so that's just you wrap an IO around the value 1. You then want to flat map the value and just add a 1 to it and return another IO with the value 2. So this looks a lot more like something you write in imperative style. So you have the value that you're extracting from that IO object using bind. So all bind does is it says, okay, whatever is below, I want to treat it as if it's inside a flat map. So A essentially just becomes an integer, and you can do 1 plus 1, and then use that value back. And since this is wrapped in an IO.fx, it will wrap the result in an IO object. And that's essentially what monad comprehension is. So let's look at, oh yeah, this is another way of doing it. Instead of using bind, you can use like brackets around the variable, and that will essentially do exactly the same thing. So now with this knowledge, let's see how we can rewrite the code above. And now that just becomes this. So we use like comprehension over the either type. We get the result for user 1, for user 2. Then we we do the same thing. We get the posts for user 1, the posts for user 2, and then we just gear the posts 1 and posts 2. And with this, you automatically get the same short-circuiting on exceptions, on rather left values that you get with either and flat maps and maps. And you also get the benefit of writing more sequential code. And that's, and finally at the end, like you just fix the value up and then you return, you do the same map for the converting throwables to the string, and then you return that. And that sort of brings us to the end-ish. We spoke about a lot of things. We spoke about the various data types that Arrow provides. We spoke about some fundamental definitions that are required in order to even start looking at the Arrow documentation. So now you can pretty much look up the Arrow documentation, go and look at a type, a data type, and pretty much know some of the concepts to figure out what exactly it's doing. We couldn't have gone through every single type because there's a lot of them. So I thought that I'd spend some time just to talk about the different types of data types so that you sort of have an idea of what you can work with. So the core data types are like ID. So ID is essentially like just a dummy wrapper monad. It doesn't really do much. Option, either, we spoke about those. Eval is an interesting one. So it basically creates like a lazy evaluated function of your functions and adds memoization to it. The great thing with functional programming is if you're working with pure functions, then you can memorize the return values. Tuple n is exactly what you think it is. There's not much to describe there. Some general use data types. You have a non-empty list, exactly what it says, a list that is greater than size 1. You have something called IOR, which is like an inclusive OR operator. So if you think of the either type, either is like an exclusive OR operator. So IOR would be, you can either have type A, or you can have type B, or you can have both. So just like either branches your code in 2 ways, this branches your code in like 3 directions. So one of the examples on Arrow's website is if you want to represent logging, you can have a value or an error, but you can also have a value and a warn. So stuff like that, it comes in handy. What else do we have? We have error handling. We spoke about try, that's going away. Validated is sort of a good way if you have a whole bunch of operations or you have a whole bunch of computations that you want to do and you sort of want to aggregate up the errors. So if you think about form validation, for example, you want to know what's wrong with your form. You want to aggregate that up and say, hey, your password's wrong, this is wrong, that's wrong. So validated is a good monad to use in that case. Yeah, read, write, state, that's a whole bunch of other things that deal with effects. You have wrappers. So wrappers basically wrap Kotlin types. So you have list K, sequence K, set K, observable K, and a whole bunch of other types that basically give you monadic functionality and good interoperability with with Arrow. So these are essentially just extension of that. Yeah, and then you have transformers. So what transformers are, something that we did not cover today, is if you have a really deeply nested, like I sort of cheated. So if you look back here, we have that really big type. What's it back here? Yeah. So you have like deferred of either, of throwable, of list, of posts and stuff like that. So that's deeply nested. The way that we got around this and used monad comprehension is because we call like a weight within like the monad comprehension. But in general, when you have like deeply nested monads, they don't really compose well. So you need to use something called a monad transformer, which is sort of like a super monad, which gives you the ability to say, okay, I have this type, I have an option, but I have something. I have this option, but I have something that wraps the option. But I want to access the value within. So how do I do that? So you use like an option D monad transformer. So yeah, that's definitely something to look into. It's a lot of cool stuff. And then finally, like the effects. So we spoke about I/O. There's a whole bunch of other things as well. I don't know why async is not on here, but yeah, we have a whole bunch of other monads and type classes that deal with effects handling. So these are some resources that does not show well, but yeah, these are a whole bunch of resources that you can use. I'll share the slides to learn more about Arrow functional programming in general. A lot of these, especially, I really like the one about the functors, applicatives, and monads and pictures. That is by far like my favorite thing ever. It explains things so simply. It's really easy to follow. So I do recommend that everyone takes a look at these links. And that's pretty much it. You can reach out to me anywhere. This is my social media. Yeah. Questions?
I think modern monad has been introduced by Haskell, functional programming language. Are you aware if there is any difference between Haskell view of monad and this one in Arrow?
So the concept of monads is actually a mathematical concept that comes from from category theory. So the idea of a monad is the same, however implementations do differ. So if you look at monad comprehension here with Kotlin, it's not the same as monad comprehension in Scala or Haskell. So the implementations do differ, but the actual core ideas are pretty much the same. Yeah, you had a question?
Yeah, do you use Arrow?
Do I use that? Yes, I have used Arrow, like mostly like on side projects and stuff like that. But yeah.
How do you like it?
So it depends on sort of how you use it. Like a lot of these abstractions, you get a lot of things for free. You get a lot of like error handling and stuff like that. That is like super easy to pick up and use. I found it less useful. I found some of the more advanced features like less useful in terms of like higher kinds and stuff like that. You can do some really cool stuff. You can write a function that is completely abstract of the type of container you want. So you could write like an API layer that works with Kotlin coroutines, that works with RxJava, that works with anything you want, just by passing in like the type of the container. So you can do really cool stuff like that. I found that less useful, and I also don't see how much value there is in going like purely functional and having only one site for side effects. So there's a lot of stuff going on, but overall I think that it definitely increases like the safety of the code that you write. So yeah.
So do you find it easy to read the code because there are a lot of syntax overload? Yeah, I mean you have to know stuff when you read the code. Yeah.
Yes, I agree. So like we've at two places that I've worked, we've actually started writing a lot more functional code, and it's done a couple of things. One, like you can see the benefits in terms of like safety and stuff like that. It also does create more succinct code, but it's also like a learning curve for anyone else who wants to write code in a more functional style. I think the degree to which you want to write functional code varies. So I know Duolingo, for example, they've written like the most mission critical piece in like Scala because they really need that safety. the team is small enough that they can train everyone on the team to write functional code. So yeah, it really depends on your use case. It for sure is a higher barrier for entry for any new hires and stuff like that. But after a point, it does get easier to understand. But there's definitely a reduction in terms of like learning. Yeah.
What do you feel Arrow interops with like the rest of the ecosystem? So whenever you interoperate with Kotlin standard library or like third-party libraries that you work with, how much effort is there to kind of like try to shoehorn it into the way Arrow models what the universe?
So Arrow sort of makes the integration as easy as possible. There are still some places where it's a pain. Like you did notice probably a bunch of places that had fix. So that is because it's trying to downcast into like Kotlin standard library stuff. Arrow does sort of make it as easy as possible, but there are these places where you sort of have to join the two. It's getting better. There's a lot of development that happens. Like every release, there's just so much that changes, and the developers like really are committed to the library. So it's going to get better, but it's not like seamless. There are some pain points. It's not too bad. Any other questions? Yeah.
Can you debug the code by putting breakpoints and stuff?
Yeah, you totally can. Like it works just the same. Like, it's just that now you have to put like breakpoints within that.
So do you have any situation where the bug was so complicated that you have trouble debugging it?
Let's see. I mean, the one thing that might be an issue is like if something breaks and if you don't handle it right. So if you wrap like your whole main with like a single try and then just catch everything into a single monad and just ignore it, then yeah, you're gonna have issues because things don't break as much. Like you don't have stack traces to know when something goes wrong. So if you're not handling and logging things correctly, things can break silently. But that's sort of also like the benefit. Benefit is that you know that this is something that can fail. So it's your job to sort of handle it. If you don't handle it, then yeah, things can break silently and then it's going to be an issue debugging. But I don't think that I've had like crazy issues where it's really hard to debug something. Yeah.
Yeah. Since there's so much wrapping going on, have you looked at the memory consumption of applications that use Arrow?
Yeah.
Like normally in Kotlin you use the null types, which it's not a primitive, nothing's wrapped. Whereas here everything is wrapped in an option.
Yeah, I haven't looked at the memory utilization, but I am so sure that it's not going to be like trivial. Like there is going to be a performance overhead to this. I don't know how much, but that's a good question. Probably there is some stuff on time to figure that out, but no, I'm not too sure. But like this is sort of a trade-off. Like especially with like with immutability and stuff like that, a lot of times to modify it is like more expensive. Similarly, there are going to be memory costs to this as well.
And by the way, is Arrow JVM only or does it run on other platforms?
I think that if it doesn't already, that they're definitely looking to support like JavaScript, right? I don't think that there is. I think that you can right now, but I haven't tried it out. Yeah. Yeah.
Does Arrow have compile time hooks such that when you compile it also generates in code?
Yes. So the extensions, so the annotations mainly, they do a lot of code generation for like static classes, extension functions, and stuff like that. So like some of the annotations literally do generate extension functions. So for example, you can say link list.k and it will return an instance of list k. So they do generate those sort of extension functions whenever you have type classes and stuff like that. It also does, because type classes are not a feature of the language, it does need to do code generation to make sure that you can apply map to these things, stuff like that. So yeah, there is a bunch of code generation that happens. Anything else? I'm going to be here for a while, so feel free to ask me any questions. Cool, thank you.